Joseph Iris, please. Demystifying Machine Learning for Programmatic UA and Retargeting. You rock.
Mine sounds much better than the other one, so I don't know. I'll let some people clear the room. Hey, everyone. Good to see everyone. I hope everyone flew in well. If they flew in, I guess there's a lot of locals. We try to build this to be as unbiased as possible and not a push to use our services. I hope it works that way. I'll get some feedback offline from you guys later. But yeah, anyway, before we start, I wanted to give you like a data-oriented intro to myself because we're talking about data, about machine learning, so I guess that would kind of work. So this is kind of my life in numbers. You can see the experience in my hairline. Obviously, EdTech is like basically a nightmare we all like love and hate. I have one lovely life that's also surprising to some of you, I know, based on how little you know of me so far. 2 adorable kids, one turns 4 in a couple of days, 2 dogs that it's really not fun having most of the time recently. Way too many pets in general. The one cat mentioned here is not really necessarily the worst one. The other one had this point in time where it just came up, stood on my chest and sneezed in my face to wake me up. I don't know why. And yeah, a team of very Russian and very, Eastern European opinionated data scientists that I really like fighting with. Way too many hours playing Apex. I don't know if there's any people from Respawn here. It's not the mobile version, but it's a lot. And yeah, all of this comes up into one big adventure. We're going to talk about a few things here. Basically, the main concept around the word demystifying is really to get you people acquainted with like the underlying principles of machine learning, why you shouldn't really be scared of it, because it's not really that complex when you get to the bottom of it. And to explain how it applies to our use case with some examples of how we built our solutions. And eventually, obviously, talk about the elephant in all of these rooms, about the loss of signal for iOS and Android, and some practical advice about running with programmatic DSPs that actually use machine learning and don't just say they do. So when we're talking about programmatic, generally speaking, just to give you like a big picture idea of how this works. Generally speaking, in the infrastructure, you should have some sort of solution to start off a campaign for the cold start problem, where you don't really know anything about the audience that you're targeting other than very general things. It can be some segment generator or something building cohorts that you would target first, or something demographic. Then you have the bidders that actually bid on all the auctions. We have like basically 100 to 300 milliseconds where we can bid on an auction. You log all of that data, feed it into a model, which is basically just an image of yesterday, if you think about a machine learning model, right? There's no magic there under the hood. It's math, statistics that you probably all learned in like a couple of courses in your degrees or whatever, or you just know the general idea around it. It's just basically how well can you remember yesterday in the right dimensions, right? So when someone says a model, that's what it means. It's not like, I don't know, there's nothing crazy there. The last thing that happens there, you can see this looping back from the model into the bidders. This is basically the actual learning concept. Every day, every few hours, depending on how you build your tech stack, you would update your model with new observations, new impressions, new clicks, new installs, and this way, you should be able to learn. That's the actual learning, yeah, seeing new things. Yeah, so inside programmatic, in the 100 to 300 milliseconds we have, a lot of stuff needs to happen. There's a bunch of predictions. A lot of them obviously around the user engagement, predicting a click given an impression, predicting an install given a click, predicting an event given an install. There's also an install prediction based on the view only, obviously, because view attribution is a thing. And last but not least is actually what we call bid shading in the industry, because everything, all the auctions in programmatic went to first price auctions, meaning that the price you pay is actually the CPM that you pay. You have to predict the market price to not pay over it, so you shade your bids. kind of like in 300, we fight in the shade, if you know that reference. So yeah, all of that gets us just to the impression. In terms of like the DSPs that try to, manage all of these things within the time limitations, you have two types. It's kind of simplistic, but this is kind of the best way, I think, to look at it. On the one hand, you have the ML-based ones. When we say custom predictive modeling, we basically mean a set of rules that is determined over time, but it pronounces really complex relationships. For example, an exchange can realize if a specific cohort, a model can understand if a specific cohort enjoys seeing ads at the beginning of their sessions or at the end of their sessions. So it really depends on which dimensions you build, how detailed you go, and that way you can get like very, very specific outputs. The other end would be more rule-based. You would have this sort of like line item structure where you can set up line items based on like different dimensions, like the example here where it's like the store category, the ad placement, and the device type, and you can set bids. Over this, you can set all sorts of rules to basically stop buying where performance is ineffective. You can set up a rule where you're saying, okay, if I'm getting more than $10 CPI, just stop buying there. So this kind of, it lives, but it's not learning. There are rules, and it adheres to them. You can add rules, you can change them, and it's very Sisyphic and takes a lot of time. The learning aspect of machine learning is something that's very difficult to visualize, and it was very important for us to do that anyway. When we came into this, we didn't know one thing about machine learning, so we wanted to make sure we can visualize it and explain it, because you can. If you get an example, so if one of your partners says it's a black box, he's either being lazy or lying, because eventually, in order to run within 100 to 300 milliseconds, you need something that's not that much of a black box. Otherwise, you can't really do much. So basically, I want to start with this visualization. What you're seeing here, the dates basically represent the same model being trained day after day. The x-axis is the probability of an event happening, in this case, an install. You see it in groups of 5%. And the y-axis is the percent of users from the targeted population within that probability group. You can see here, when it starts off again, that at the beginning, most of the users are basically at 0, yeah? Because the model doesn't know how to discriminate between them, how to classify between them. Over time, you can see the distribution normalize, and basically all the users on this end are users that are gonna get higher bids, because we know there's a higher probability of them converting. So this is basically how learning looks like in terms of like the users that you target. Basically, one pain point for programmatic DSP is getting basically exploration done in an effective way. You don't want to spend $25,000 with a DSP to get one paying user, right? We heard that happening. So yeah, basically, in order to start off effectively, you need some sort of cold start solution. We have one for iOS, we have one for Android, basically. Some sort of general segmentation or some sort of approach that can help us start from something where we don't need to learn something we already know. If you're promoting a match-free game, there's no reason to target a 12-year-old boy because he only cares about Fortnite, right? It's still popular, I think, Fortnite with 12-year-olds. So yeah, we need to avoid that. The last thing is with your cold start approach, you want to be careful about building something too specific that would be considered overfitting. Basically, you would be learning only a target population that converts at a very high rate. Obviously, most users don't convert at that rate. If you feed your machine learning only that, it's going to overfit. It's going to think all the users are going to convert amazingly. And then when you try to scale, it fails miserably. We were there, and we had to figure that out over time. The other thing, which I think is the most important thing about working with a DSP that runs machine learning and doesn't just say it, is to be transparent and to explain what's happening under the hood, because you can do that. There are all sorts of tools. Generally speaking, based on our experience and all the literature that we read as well, solutions that are too complex to understand, even if they're considered to be the state of the art, usually don't outperform the very, let's call them, common sense approaches. So that's, again, when someone says, it's a black box, I couldn't understand if I want, don't buy it. Doesn't really make sense in 99% of cases. Definitely in our case, because of the time limitations that you have like 300 milliseconds, you can't compute, you can't like split atoms in 300 milliseconds, right? Maybe you can, I don't know, like all of that physics stuff, but you get my point, I guess. So for example, this is like a visualization of like the graphs that we show our partners about feature importance, right? So in this one, if I can explain it briefly, the gray line stands for 0, no impact on the probability of something happening. Everything on the left decreases it, everything on the right increases it. You have the features listed in order of importance. Red stands for high value and blue stands for low. That's a lot, but like you get used to it very quickly. So an example here, we see that rewarded placements increase the probability, and that the closer the context is, the performance improves. So these are things that can be explained basically with any machine learning model that isn't like considered a full black box, but even the more complex ones support something like this. So we believe this should be the minimum in terms of transparency. Yeah, so the hard thing and loving scan, that's kind of a lie. It's more of a love-hate thing, where I love hating it. But yeah, scan is like, you know, not great in terms of like what we can do with it as an attribution solution. But eventually, obviously, there are ways to work around it, right? Basically, we're losing context. Sorry, we're keeping only context and we're losing everything else, right? We only know where we're buying the ad, and we can relate it to the ad we're promoting. Other than this, obviously, the changes with scan, you lose signal, but the prices of the auctions decrease accordingly. So eventually, machine learning can still be applied. It just has less signal, learns a bit slower, but the decreasing prices help with that. Now, the way to work with context in order to work either inside scan limitations or generally speaking, how to target on iOS, the way we see it, you have 3 main solutions. The first one is actually using store categories for whitelists and basically seeing if your app works well on one. ASO makes this a nightmare because people change their categories every couple of weeks to increase the ranks. The other one, which takes a lot more time and maintenance, is manual tagging, creating your own categories. That's something pretty common in the industry and in any industry. It's also called a mechanical Turk. That's like the service. It works, but it's not that scalable. Every time you have a new app, you need to tag it. Every time you have new words, you need to consider them. And NLP, which is basically natural language processing, not the other kind that's used for coaching, lets you do this automatically. Basically, you can represent an embedding of an app that captures its content. Basically, inside app descriptions, there's mostly the truth about what's happening inside the game. You can see like the mechanics, the theme, and if you can capture it in a way that machine learning can understand it, you can do some nice stuff, right? So the way we did it, we're using a model called Elmo because machine learning guys love obscure references to the Sesame Street for some reason. But basically, it lets you take the words inside the app description and represent them based on their weight. Weight being their like rarity. Basically, the more a word is rare, the more it's meaningful for the content of the app. And basically, using vector math that I don't know much about, but it works, you create a representation of an app that's a vector. And when you have vectors, you can measure distances between them. So you can pronounce the contextual relationship between 2 apps in a number that ranges between 1 to 0 if you choose to normalize it. And then you can build dynamic whitelists off of this using normal structures of scan campaigns or whatever you do. But it's much, much more dynamic because each new app just gets its embedding. You don't need to worry about maintaining it. Another huge part of machine learning and applying it to programmatic is creative selection. You can do really amazing stuff and improve your performance when you do it correctly. In terms of like the methods that exist, we all know A/B testing, obviously. We wrote instant regret there because of the associated regret cost, right? You're running an A/B for a week. You're regretting all the costs that went to B that sucked. So when you're building a more robust solution, like what's called a multi-arm bandit, that's basically coming from The allegory is for like a one-armed bandit is a slot machine. It's basically an algorithm that's designed to find the best slot machine that's gonna win. That's why they call it that way. But basically, as you can see in this image, you can see that from the start, everything is split evenly between all of your creatives. In real time, you capture the best performing one in terms of click rate or IPM, whichever one makes more sense for you, for your use case. And straight from the first target that you get, the first install, it starts getting more and more inventory. So this is like a real-time A/B test that feeds with each target that you get. So it's really, really useful and much faster to converge. The next one we have is contextual bandits, which is basically the same thing, only with more than one champion. Yeah. So the best example I can give here, let's say you have a game. This is when you're using the multi-arm bandits thing I described before. You have the champion, it has the highest IPM, it gets 90% of the inventory. The other ones get split according to their performance. As you can see, the IPM is decreasing. In reality, you're targeting much more than one group of users, yeah? Even when your game is a niche, you have more than one persona. That's just the reality. It doesn't have to be a game, but you get my drift. So instead of just selecting a single champion, you pronounce the context of the users to the model, basically saying all sorts of demographic features about them, and you choose creative based on those attributions of the user, attributes of the user. So this way you can, as the example shows, get higher IPM overall because you're targeting the right creative to the right person. Like the classic example is the difference in like age or gender, basically. Older people care about one thing, younger people care about the other, and yeah. Last thing I wanted to share are some actual practical tips for you guys when you're about to work with a DSP. So the first thing is making sure it's an actual DSP. When my father described our business of edtech to older Jewish people, rabbis and stuff like this, about like what we're doing, he used the Yiddish word that says business in the air, right? So basically people can just throw around, I'm doing machine learning, I'm a DSP, do your due diligence, ask them the right questions, see that there are more than 3 people on LinkedIn, and yeah, question those stuff. Data sharing is critical, obviously, both to avoid targeting existing users, but also to help the machine learn faster. So after you do your due diligence, make sure there's an even playing ground because social has all of this data. So you want to make sure your DSPs have the same opportunity to run at the same performance. Be clear about your goals. You'd be surprised how many cases we get KPIs that are basically, I had one campaign in 2019 that had this amazing performance on this very, very tiny bit of audience. That's not a realistic KPI. Give us an average, give us something that makes sense, build it in a way that's like gradual, you know, because basically, as the next point says, there has to be some patience for the machine to learn. Obviously, you don't want to go too far because at that point you start being frustrated and money is just being burnt, but be careful. I repeated this many times throughout the presentation. Feel free to ask questions and feel free to ask for time for the right people to ask the questions. You're spending millions of dollars a year on these DSPs. You can ask for in half an hour with a product manager. They'll come out of their cave, they'll shave or something, they'll bathe once that month, and you can ask them the questions. And yeah, the first original writing for like the phrasing for the last point was, if it quacks like a duck, it's click spamming. I like that joke better, but other people don't. But really, I mean, if something really looks good to be true, it's basically your organic being stolen. Again, this still happens. It's sad, but it still happens. So just be aware. And yeah, thank you.
Do we have any burning questions? We've got time for one question, so make it a good one for Joseph. Does anybody have a burning question? Joseph, you are free.
I just answered everything so
You're
so.
full of like machine learning answers, that's why.
Thank
you very much indeed. Cheers. Thank you. Another round of applause, please, for Joseph.